Another way of graphing a linear function is to graph our intercepts. Remember I said we only need 2 points? Well, intercepts make it easy because notice when we made our table, nice things happened when we used 0, didn't we? So that's what we're going to do when we use our intercepts, because our intercepts, we're just going to make each one 0. I'm only going to use 2 points. So what I'm going to do here is I'm going to make my x and y intercept. I'm going to do my y-intercept and my x-intercept. So I'm going to make x0 one time. That's my y-intercept. I'm going to make y0 the next time. That's my x-intercept. So to find my y-intercept, I'm going to replace x with 0. So in other words, since I'm replacing x with 0, I don't need that first term, do I? That's gone. So I'm just going to solve 2y equals 8. So divide by 2, y would be 4 then, wouldn't it? So I'm going to graph the point 0, 4. That's my y-intercept. Now I'll turn around and I'll do my x-intercept. And once again, nice things happen because y is 0. I don't have that term anymore. So I just have negative x equals 8. Whoops, need my pen there. I was wondering why it was so thick. Negative x equals 8. I want x by itself, so I divide by negative 1. So x equals negative 8. So then I'll go to the left 8. And I got 2 points on my axis. And I draw a line through those. Could I draw another one? Sure I could. But I think my x and y intercept make it kind of nice to only do 2 points on that one. Now let's take a look at an application problem with that same value. It says, Angelina bought a 15-pound dog bag of food for her dog. The bag contains 60 cups of food, and she feeds her dogs 2.5 or 5/2 cups of food per day. This function represents y plus 5/2 x equals 60, represent the food left in the bag, y, after x days. Graph the amount of food left in the bag as a function of time. Notice I only have the first quadrant here. Why do I only have the first quadrant? Well, I only have the first quadrant because I don't have any negatives. I don't worry about that. So I have time and I have food left. Now, I might have to adjust my numbers, my axis, and my scale. So let's just find our x and y intercepts first. So I'll go x and y. I'll go 0 and 0. Let's find the y-intercept first. So that means x is 0. Since x is 0, look at that. I've got y equals 60. So I need to get up to 60. And I think what I'll do, let's count then by, let's count by 5s. I think that would be a nice one. So 5. Now, I'm counting by 5s. Doesn't mean I have to write down every number every time. So go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And there's my y-intercept at 60. Now let's turn around and let's find the x-intercept. Which means I'm going to make y 0. So I have 5/2 x equals 60. I'm just going to solve that equation, multiply both sides by 2. Remember, reduce your 2's on the left side because I don't want you to write You don't multiply 2 times 2. It's actually 2 over 1 if you think of it that way. So it's 5x equals 120. Then I'll divide by 5. And check with my calculator. 120 divided by 5 is 24. You do not have to have the same scale on your X and Y axis. So I need to go out to 24, and I think if I count by 2's, that will give me enough. So time is going to be by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 is where I put my dot. I could keep on going from there. And then draw your line through those 2 points. And there you have it. That's how much food you would have left after each time. So notice, after 24 days, I'd be out of food. When I started, I had 60 pounds of food. And then any point on that graph will tell me how much food I have after that number of days. I do believe that is our last example. I want to double check. Yes, it is.